In today's video, we'll be making animated snowflakes with GreenSock. We're going to take this sort of boring version on the left where everything's moving at the same speed and turn it into this more dynamic and fun version on the right. We're going to make it so that the scale of the snowflake determines the speed that it's dropping and its opacity. Larger flakes will drop quicker than smaller flakes, and we're going to use GreenSock's Interpolate method so that we can force things like the scale and opacity into predefined ranges. This is a really cool technique that can be applied in limitless fashions throughout your projects. A lot of the concepts we'll be using today we've talked about in previous lessons. In our bug race game, remember we had the bugs moving across at different intervals? Well, in the JavaScript code for this, remember that we had this moveMe function where moveMe would take in a bug, it would create a tween, and when that tween completes, it would pass that bug back in, so we get all these different tweens for all these different bugs. Our snowflakes are going to be set up in the same exact way, so check out this lesson if you need a refresher. And we'll also be using the concepts from hacking GreenSock eaves curves for weighted values, so definitely watch these two lessons first. I'm going to give a quick overview of our file setup and then get into the meat of using interpolation. So let's do a little walk through the file we're going to be working on. First things first, to create a flake, we're going to have a div with a class of flake, and then flake 1 here means it's just using a particular background image. If I switch this over to flake 2, you're going to see that now the flake is going to appear different, and I also have a flake 3 and a flake 4, so maybe flake 4 will be a little bit of a surprise, okay? So in order to animate a bunch of flakes, we're going to create a bunch of divs with a class of flake and then a flake number, okay? So we don't need that anymore over here. And in the CSS, really quick, I'll show you that we have our generic flake class, which just gives position absolute, a width, a height, background, size, cover. And then these flake 1 and 2s and 3s and 4s just use a particular SVG for the background image. Over in the JavaScript right now, I have nothing. But you know what? I'm going to paste a whole bunch of boilerplate code in here. And it would probably take me a half hour to type this all out for you. And we've done about 90% of this in recent lessons, okay? So let me just run. We'll see what we get. I'll walk through the code, just show you the basic setup. And here we go. We have a whole bunch of flakes coming down. And you'll notice that it's all animating at the same speed, okay? There's really no depth. It almost looks as if maybe a big roll of wrapping paper is sort of coming by, all right? Just flake after flake, regardless of what size these flakes are, they all move at the same speed. One of the issues I have with this is that some of the flakes are really, really small, like right here. Oops, every time I click it plays. So I'll just point, and we have these sort of minuscule flakes that really don't do anything for us. And I imagine there's some that are so small we can't even see them at all. So one of the things we're going to fix is to make sure that our smallest flake at least has a minimum size, okay? So that's one of the things. And then we're going to make bigger flakes move faster than smaller flakes. But before we get into all that, let's just go through the actual code here, okay? So first things first, I have a variable set up for the number of flakes. We're using 50 right now. And we're getting width and height variables on load based on the window inner width and inner height. I have a function set up whose only responsibility is basically to create a new div, give it a class of flake, and then for which graphic we're using, we're going to dynamically append a random number between 1 and 4. So we're going to have flake, flake, and then some number. Using GSAP.utils.random in this fashion, we're getting a number between 1 and 4, and we're snapping to whole numbers here, increments of 1. We're going to give the new flake the class of flake class, which I just created right here, and then we're going to append that flake to the DOM, right into the body. So whenever we call this function, we get a flake back. And I want to show you that we have a loop set up. Based on the number of flakes, we're going to create a flake based on what create flake returns, and then we're going to call animate flake and pass in that flake. Now let's look at the animate flake function. We're going to pass in a flake, and we're going to give it a scale based on an ease curve. Check out my video on hacking ease curves if you haven't already. But basically what this is going to do is use an ease curve to distribute the size or scale of the flakes. Right now I'm setting up just a duration of 5, which is used for every flake's animation, which is why they all appear and are moving at the exact same rate right here. Once we create a flake, or I should say once this animate flake is called, we're going to use a GSAP set to set the Y to be -200. So we just have enough room off stage to the top to place these things. We're going to randomly put them between 0 and the full width of the screen. And the scale is going to be set to our scale factor. I might have skipped over it, but scale factor is going to be a value between 0 and 1 based on this ease curve and the random number that goes into it. Similar to our bug race game, as we move the flakes down to a Y position based on the height of the browser plus 200 pixels so that we get fully off screen, we'll have a random delay, no ease, but when the animation is done, on complete, we're going to call animate flake again and pass in the current flake as the onComplete params. So when the tween completes, that flake is going to get rescaled, repositioned, and drop at a different speed each time for a fully random experience. So again, definitely check out my videos on the bug race and constant speed as we go over all this stuff already. Now you may say, Carl, for the duration, yeah, you're just setting that to 5. Why don't you make that a random number? And I can. I'm going to do a math.random really quick here and multiply that by 5. And that's going to make things look a little bit better, but I don't like the fact that, everybody just sort of has a random speed. Some of them are like super fast. And I really want to go for the effect where the speed is based on the size of the snowflake, all right? I want to create this illusion of depth where larger snowflakes are closer to us and thus appearing to move faster, and snowflakes off in the distance will be moving slower like you would with a typical parallax effect. And when you do math.random times 5, you could get very, very small values, all right? In order to get the bigger flakes to move faster, we're going to step into an isolated demo and really get into it. In my starter file here, we have 2 snowflakes. We have a small one and a big one. Right now, they're the exact same size, and we're going to use some JavaScript to change that around a little bit. So let's go over to my JavaScript panel, and I'm just going to paste in some code real quick. We're going to have a small scale and big scale variable that we're going to apply to the small flake and the big flake, all right? Small scale is 0.2 and big scale is 0.8, and we'll do that with these sets here. So let's run, and as you can imagine, it's going to make this first small flake smaller than the big one. Now the trick is we want to animate the big flake quicker than the small flake. Right now I have 2 tweens set up, which are basically going to animate them both to an X of 800 with the same duration, which I have set to 10. So you really don't need to see this, but just to be safe, there you go. They're both moving at the exact same time. Now, in order to make them move at different speeds, what I can do is use their scale as a factor of the duration of the tween. And what does that mean? Well, for the small one, I'm going to start out by saying that the duration is going to be the small scale value that I have times duration. And what that's going to look like is we're going to have 0.2 times 10, and that's going to give us a duration of 2 seconds. Likewise, if I go down to the big snowflake and use big scale and multiply it by duration, I'm going to get something that looks like 0.8 times 10, which is going to give me 8, all right? I'm using very, hopefully simple numbers here. Now, is 2 bigger or smaller than 8? Well, we know it's smaller, and in the terms of duration, a smaller duration is going to move faster than a longer duration. So let's run this, and that makes the small flake move way faster than the big flake, okay? So what I want to do is show you how we're going to flip this around to make the big flake move quicker than the small flake. I created this chart to show you that I can subtract the scale from 1 to convert a small value to a big value. What does that mean? Let's say our scale is 0.1. If we do 1 minus 0.1, that's going to give us 0.9. So a small number turns into a larger number. If I take 0.4 as my starting scale and I say 1 minus 0.4, that's going to give us 0.6. So again, a small number goes to a larger number. And inversely, if I take a large starting number like 0.9 and subtract it from 1, I'm going to get a small number like 0.1. So the trick here is to take my scale value and subtract it from 1. To apply that in our code, I'm going to do 1 minus small scale and wrap that in parentheses so that operation happens first, and do the same thing with the big scale. 1 minus big scale, and then multiply it by the duration. So now what we're going to get is a little flipperoo, and you're going to see that we're going to have the big star move quicker than the small star. Let's see. Woo, there we go. The big star is already done and the small star is moving much slower. Now this does solve the problem of having a big thing move faster and a small thing move slower, but I really don't like the fact that there's such a huge discrepancy between the speed, all right? Check it out. This snowflake's already done and we're waiting forever for this one. And just so we see it, right now, the small one is taking 8 seconds and the large one is taking 2 seconds. There's a big gap there between those two. Well, what if I wanted the smallest star to take 4 seconds and the largest star to take only 2 seconds? Well, that's where interpolation comes in. Interpolation allows us to take a progress value and map it to a range of values. What the heck does that mean? Well, let's go into our console here, and I'm going to tap into gsap.utils.interpolate. All right, and I said 2 and 4 before, all right? But for now, let's just say that our lowest value is 0 and our highest value is 10, and I want to figure out what number is in between those two numbers. Well, I'm going to pass in a progress of 0.5, which means halfway, and then you'll see that my value is hidden here and it's going to give me 5. If I do something like gsap.utils.interpolate again, and I do like -100 as the low and 100 as the max, and say, oh, what's halfway in between there, and say 0.5, maybe you can guess. It's going to be 0. Let's see, hit return, and there we go. So what I want to do is use this in my code up here so that I can sort of set the high and low values of my durations. So let's go up here and I'm going to create another variable and I'm just going to call it a small duration. And that's going to be equal to gsap.utils.interpolate. And we're going to use 2 and 4. And for this progress value, I'm going to pass in 1 minus whatever small scale is, okay? So we're going to be pretty much not doing all this work in the tween. We're going to figure it out up here. And then I'm going to get rid of all of this here, and I'm just going to use small duration, okay? So basically we're going to say if small scale is going to be, what are you, 0.2, we're going to get 1 minus 0.2, which gives us 0.8, and we're going to map 0.8 between 2 and 4. What's that going to do? I don't know. Let's just figure it out. Let me type in gsap.utils.interpolate 2, 4, and 0.8 is going to give us what? A duration of 3.6. So that's going to be pretty much close to 4. Let's do the same thing for our big duration. I'm going to copy that and I'm going to paste it and I'm going to change it over to big duration, and we're going to subtract over here our big scale, and then in my tween we're going to get rid of all of this here, and I'm going to say big capital D duration. These numbers no longer apply. That was 3.6. Let me close out my console and let's run. And now you're going to see again, the big one moves fast, but the small one is moving just a little bit slower, okay? we don't have that huge gap anymore. If I wanted to, I could play around with these min and max values here. Maybe I could make them even closer together, all right? Maybe there isn't going to be such a huge discrepancy between the fastest and the slowest star. But again, you're still going to see that there is a difference in speed, okay? And to further help us understand, I've updated my chart with a new column for the interpolated values. So let's say we start with a snowflake with a scale of 0.1, very small. If we subtract that 0.1 from 1, we're going to get our flipped larger value of 0.9. So we're turning a small value into a large value. If I pass that 0.9 into the interpolate function with a minimum of 2 and a max of 4, we're going to get something towards the high end of 3.8. And so a snowflake with a duration of 3.8 seconds is going to be moving much slower than a larger snowflake that has a duration of 2.2 seconds. So now that we've mapped this all out, let's apply what we've learned to our big snowstorm. All right, that was a lot of talk about interpolation and flipping values around. Let's see where we left off. We had, remember, a random duration between 0 and 5 seconds, basically, and that gave us something like this, where some things could be moving at a super fast duration or a super slow duration, and there was no speed based on the size of the star, and some of those are just way, way, way too fast. So let's put into practice what we were just talking about. So for the duration, I'm going to use gsap.utils.interpolate. And let's just say we want a range between 2 seconds and 4 seconds. So the quickest flakes will be moving at 2 seconds and the slowest ones will be moving at 4 seconds. Now the trick here is we're going to put in our scale factor. And it's important to remember that this is going to return a value between 0 and 1. So just by putting in a value between 0 and 1, we're going to map that 0 to 1 between 2 and 4. Let's see what we get. Aha! Let's think about what's happening here. It looks like the smaller flakes are going past the larger flakes, okay? So the smaller the flake, the faster it's going. We just had a very big flake here. They're going pretty slow, and the small ones are going fast. And that's kind of the opposite of what I said we were going for. So remember, the special sauce here is that we want to flip the value around. So we're going to do 1 minus scale factor. So if this value here for scale factor is 0.1, 1 minus 0.1 is going to give us 0.9. And when we interpolate 0.9 between 2 and 4, we'll get a duration of 3.8, which is on the higher end of the scale, meaning a longer duration, meaning slower. So the larger the value we get from 1 minus scale factor, the slower we're going to move. Let's do another run. And now we should have things pretty close to what I want. Ah, you see that? The bigger flakes are now moving past the slower flakes. Ooh, look at that big one go. And you have these sort of real tiny ones going slow in the background here. Very cool. So let's address the fact that some of these flakes are so small that I can barely see them, and maybe I want the big ones to be much bigger. Well, right now, scale factor is returning a value between 0 and 1. Well, what if I wanted that to be bigger, like maybe 4? Well, I could sort of just tack on a 4 here, and that's going to increase the size of my scale factor. But watch what happens. We get into a very precarious situation here where we have very large flakes just flashing on and off the screen. Let me click to stop that. And you might be wondering, well, why'd that happen? Well, right here for our duration, we're using 1 minus scale factor to map between 2 and 4. And if this scale factor number is above 1, let's say it's 4, 1 minus 4 is going to give us -3. So we're going to be dealing with a negative duration, which means these tweens here are instantly finishing as soon as they're being created, and you don't even see any animation at all. So we want to be very careful to keep scale factor between 0 and 1. So what I'm going to do is create a separate variable called scale, and I'm going to use gsap.utils.interpolate and I'm going to then interpolate the scale factor to any range that I want. So maybe I'll say that the smallest flake is going to be 0.3 normal scale, and the largest one is going to be 2 times the normal scale. And I'm going to put my scale factor, which again is between 0 and 1, into that interpolation. Now when I actually set the scale of the flake, I no longer want to use scale factor. Remember, that's locked between 0 and 1. I'm going to use my new scale value. So let me just take the word factor off of here. And now you should see that we're going to have some considerably larger flakes, and the smallest ones aren't going to be so small, all right? So it should be instantly obvious that we're now mapping our scale factor between a range of 0.3 and 2 times normal scale. And hopefully you can see how incredibly powerful this is, because we can mess with these numbers all we want. I could say, you know what, let's keep them between 0.1 and 0.5. And all of a sudden, all of my stars are going to be really pretty close to the very small size. I said stars again, didn't I? But we're still maintaining that speed based on the scale, okay? So if we just want a few small snowflakes, there we go. But I really like having the smallest one at least 0.2 or 0.3. And I think going up to 2 or even 3 might be nice. Let's see how that looks. Ah, there we go. Whoa, those are some big flakes. But hopefully you can see now how this sort of depth or parallax effect is coming into play with these big flakes that are closer to our face moving faster than the ones that are smaller. I'm going to kick this value here back down to 2. And the last thing I want to do is affect the opacity of the flakes, all right? I want to make the opacity based on the scale as well. So I'm going to add another variable here. I'm going to say let opacity equal gsap.utils.interpolate. Hopefully you're seeing how powerful this is. And maybe I want the least opaque version to be, I don't know, 0.3. And of course, we don't want opacity going beyond 1. And so again, we're going to send our scale factor in there. So if we have a scale factor of 0.1, that means that it's going to have an opacity very close to 0.3, but not less than that, because we really don't want any flakes to have an opacity of 0. So this is going to help us out there. So in my set, I'm just going to add in opacity property and set it equal to our opacity variable. So now the next time I run, we should see everything that we want. Where are you, flakes? There we go. So even just looking at this now, I'm almost thinking, you know what? That opacity of 0.3 is actually a little bit on the low side for me, all right? I want those ones in the background to pop just a touch more. So again, check out this flexibility. We can just make that 0.5. And now the stars in the background are a little bit more visible. I'm loving this. So I could really call it a day here, but once you have all this stuff set up, it's so easy just to play with the variables, add new properties. And one of the things I liked adding was just some random rotation to the flakes. So in my tween here, what I'm going to do is just say that the rotation of the flakes is going to be a random value between, I don't know, like -60 and 120. We can play with that. Let me put my little comma in here. And maybe we want things just not falling totally straight down, but maybe a little bit to the right or left. Well, for that, in my tween, I can say, you know what? Your x value is going to be, I don't know, plus equals 200. And what this is going to do is give us a slight breeze moving over to the right. Let's see how this goes, and let's really crank this up. Oh, look at that. We have some random rotation going on now. They're going back and forth, and we have this really nice sort of decorative ambient snowfall going on. We could easily have some text coming across the screen and just really set the mood here. So hopefully you've enjoyed this, you've learned something, and again, once you have these particles going, there's so much you can change. And remember, if some of this is new to you, please go back to the previous lessons in this course. We cover all this stuff. We build you up step by step. So hopefully when you see stuff like this, you're like, you know what? I can do it. So please play around with the snow and let me see what you made. Check out this video to learn more about the Creative Coding Club. Join today and unlock over 90 premium GreenSock tutorials. If you liked the video, please consider subscribing to the channel and giving it a like. My channel is packed with tons of fun GreenSock tips like this. Have a great day!